All right, so we're going to do the solution to number 2 here on modeling worksheet 5, unit 5, worksheet 2. We have a block and there's a 25 Newton applied force pushing down on the block. It's resting on a frictionless surface and the force is directed at an angle of 20 degrees with the horizontal. So the first thing we always do is establish our system and draw a force diagram. So I'm going to establish the block as my system, and I know I have force of gravity acting on the block. I have this applied force at 20 degrees, and I can go ahead and draw in my components. Applied force in the X and applied force in the Y, and this is 20 degrees. And then my normal force is acting up, perpendicular to the surface. I'm going to make my normal force bigger than my force of gravity because I have two forces acting down, gravity and the Y component of the applied force, and one force acting up. And I know that the block is not accelerating up and down, so my net force in the Y direction needs to be 0. So since there are two forces down, my force up has to be bigger. Next it says determine the X component of the applied force. So to do that, I'm going to use my trig, and I know that applied force in the X direction is equal to the force applied times the cosine of 20 because of the rules of a 90-degree triangle. So cosine of theta. So force applied in the X direction is equal to 25 times the cosine of 20 degrees. And that's 25 newtons. I put a parenthesis there. And that is equal to 23.4 newtons. Then it says, what is the acceleration of the block? So to do that, I'm going to write the net force equation in the X direction. So sum of the forces in the X direction is equal to only the force applied in the X direction. There's only one force. So then I replace net force, or sum of forces, with mass times acceleration. So applied force in the X direction, and I'm solving for acceleration, so I'm going to isolate that by dividing each side by mass. So acceleration is equal to the applied force in the X direction over mass. And I didn't actually say my positive directions. I'm going to choose right and up as positive. And then I put in my applied force here, which is, we just make sure it's a positive force. It is acting in the positive direction, so 23.4 newtons. And then I'm going to divide by the mass of my block, which is 5 kilograms. And that gives me 4.7 meters per second squared. Next, I'm looking for the normal force. So to determine normal force, I need to write a net force equation in the Y direction. So sum of the forces in the Y direction are equal to my normal force plus my force of gravity plus my force applied in the Y direction. And I know my net force in the Y direction is 0. And then I'm solving for the normal force, so I'm going to isolate normal force by subtracting force of gravity and force applied in the Y direction. So normal force is equal to negative force of gravity, and that's a vector, minus force applied in the Y direction. And yeah, that's right. So then I am just going to plug in numbers from here. So I get my force of gravity is mass, which is 5 kilograms, times negative 9.8 newtons per kilogram. I have to put a negative sign there because I chose up as positive and gravity is acting down, so this term needs to be negative. And then I subtract my force applied in the Y direction. I didn't actually figure that out yet, did I? No, I didn't. Okay, so my force applied in the Y direction, I have to use trig to figure out the Y component of the applied force. So I'm going to pause for a second and do that up here. So force applied in the Y direction is equal to the force applied times the sine of 20 degrees. So force applied in the Y direction is equal to the 25 newtons times the sine of 20 degrees. And I don't actually have that solved out on my paper by itself. So I'm just gonna put that in right down here. So this is 25 times the sine of 20 degrees. But this value is a negative value because it is, it's acting in the negative direction. So when I solved for normal force here, I subtracted force of gravity. Oh, that's what I forgot. I was like, this isn't working out. I subtracted force of gravity, and then I subtracted my applied force. So I have lots of negatives here. I have -5 times -9.8, that's going to turn into a positive. And then I'm subtracting a negative, that's going to turn into a positive. So when I do that whole calculation, I get my normal force is equal to 57.6 newtons. Now notice that your normal force is going to be bigger than the force of gravity. So force of gravity is 5 times -9.8, so that's -49 newtons. And so normal force is bigger than that. So that is problem number 2. We also had to do problem number 3. And in this problem, there is a person dragging a block, and it tells you what the coefficient of friction is. Oh, sorry, it just tells you the force of friction. And you have to determine the acceleration of the box. So the first thing we're going to do is establish a system and draw a force diagram. So my system is this block, and I'm going to draw my force of gravity acting down. I know I have a force of friction acting in this direction. I have a force of tension acting at 30 degrees from the horizontal. And then I have a normal force acting up. Now, when I'm figuring out how to make my normal force, how long to make it, I know that I have 2 forces acting up, normal force and tension, and only 1 force acting down. So normal force plus tension in the y direction should be equal to gravity. So if I split my tension into Ftx and Fty, I should see that this length plus this length equals force of gravity. I'm actually going to make my force of gravity a little bit longer just to make that clear, that normal is less than gravity. So there's my force diagram. This is 30 degrees. And I need to find the acceleration of the box. So I know that I'm going to be writing a net force equation in the x direction. So sum of my forces in the x direction is equal to the force of tension in the x direction minus the force of friction. And then I know that this is equal to mass times acceleration in the x direction. And force of tension in the x direction is equal to the force of tension times the cosine of 30. So I'm going to substitute in force of tension times the cosine of 30. Now this is a positive value, so I'm going to take off, because, oops, sorry. I'm going to choose, I forgot to set my positives again. I'm going to choose to the right and, to the left and up as positive, because that's the direction of the acceleration. So I'm inserting a positive value here for force of tension, and then I have to subtract force of friction, which I already know. Actually, I'm going to keep this in variables for one more step. So I'm going to put theta there, and then put force of friction here. Oh, I put minus, oh my goodness, plus. Okay, so then I'm going to isolate acceleration in the x direction. So acceleration in the x direction is equal, I'm going to divide both sides by mass, is equal to force of tension times cosine of theta plus the force of friction divided by the mass. And now I just have to plug in numbers. So my force of tension is 400 newtons times the cosine of 30. That gives me my force of tension in the x direction. And then I am going to add my force of friction. Now force of friction is acting to the right, which I chose as negative. So I'm going to put negative 75 newtons here. And then I'm going to divide by my mass, which is 70 kilograms. And when you do that, you should get a number that is equal to 3.9 meters per second squared. Isn't physics so fun?